breaking the wall of powering machines in the nanoscale. Qualified in the Singapore lab, James Mu, Nanyang Technological University, Singapore.
A machine is an additive device that uses energy to do work and to move. Humans for centuries have been fascinated with locomotion in the natural world. The Wright brothers replicated the wings of the bird in an airplane. The streamlined body of a fish can be found in designs of boats and ships. Indeed, many constructions of modern society have been inspired by nature. However, to replicate such performances and miniaturize or the nanoscale, things are not so trivial. New innovations are needed to power these nanomachines in order for rapid drug delivery and ultra-fast environmental remediation. In biological systems, the microorganism of the amoeba typically moves by a crawling mechanism, where it slowly stretches its cellular membrane outwards. Some bacteria develop tail-like structures that enable it to flutter in water, so they can catch its prey. However, these systems are slow-moving. Nature has always been a source of inspiration for us all. The violet sea snails have developed a unique capability while living atop ocean surfaces. While one may think that snails are slow-moving, these carnivorous sea snails use bubbles to propel themselves so that they can feed on jellyfishes. Here, we have been developing a bubble-propelled nanomachine. And these nanomachines are made from deposition technique and consist of copper on outside and a concentric hollow platinum center. The decomposition of hydrogen peroxide over the platinum surface produces oxygen bubbles. The accumulation and eventual ejection of the bubbles pushes the nanomachine forward. This is much like the jet engine. We are able to achieve ultra-fast velocities up to hundreds and thousands of micrometers per second, which is 2 orders of magnitude larger than any other biological system. This raises new considerations of how such artificial nanosystems, such as ours, is able to compete against biological ones. Furthermore, we have been using these nanomachines as environmental sensors. In pristine waters, these nanomachines move like fishes in water, swimming at very high velocities. However, in the presence of lead or heavy metals, poisoning occurs. Reduced activity of bubbling are found, and there's a drastic decrease in the velocities. This showcases the ability of these nanomachines to act as first responders to changes in water quality. As the founder of nanotechnology, Richard Feynman once said, "There's much space for us to explore at the bottom." Here, we would like to add that there's indeed much room for us to move around at the bottom when we break the wall or powering machines at the nanoscale. Thank you.
Questions, comments? One here in the front.
What's the smallest size that you can push with a bubble? I suppose a bubble has a certain size.
Yeah, the bubbles are nanometer in size. We have been able to create 200 nanometer size nanomotors.
One more question.
Steer these?
Sorry?
How do you steer these?
We do magnetic manipulation, or we can use UV light to steer it. So they are like chemotaxis. They move towards phototaxis. You can add chemical to attract them, and you can use light to attract them. So they're, in a sense, they're artificial living organisms.
Final comment, question? No comments? Thank you very much.
Thank you very much.